Leapfrog has a powerful drawing tool that gives you the freedom to draw any shape simply and precisely anywhere you want. This single drawing tool can be used to create new surfaces or edit existing ones and is used anywhere line work is able to be drawn in a project. It is very flexible and allows you to create straight or curved 2D or true 3D polylines as well as single points. The tool has options to control the pitch of the surfaces by adjusting a line's ribbon orientation or by adding points with normals. In this video, I'm going to cover the mechanics of actually drawing the lines. Before demonstrating the drawing tool in Leapfrog, let's become familiar with its functionality. What we see here is the new toolbar that will appear when you create a new polyline in Leapfrog. The Draw Polyline Toolbar has a number of icons, which I'll review now so that when we get into Leapfrog, we'll be familiar with their functionality. The first option we will look at is drawing 2D polylines, which are drawn on the slicer in the scene. So the first thing you'll do is select the Draw Polylines tool, followed by the Draw on Slicer icon. The following tools are available for 2D polylines. This tool makes the lines straight, whereas this tool can make the lines curved. This tool allows you to insert an additional node, whereas this one allows you to insert a tangent. This tool allows you to flip the polarity of a node or of the entire polyline if it is selected. We also have a couple additional tools here. This one transforms a 2D polyline into a 3D polyline. And this one restores the slice that was in the scene when you digitized the polyline. You'll notice that this solid line indicates that we have drawn a 2D polyline. The next option is to draw a 3D polyline, which is essentially a polyline drawn on objects in the scene. So you'll notice that just like before, the available tools are to draw straight segments, curved segments, adding a node, adding a tangent, and then flipping the polarity of either a node or the entire tangent. You'll notice in this case, the dashed line indicates that we have created a 3D polyline. Lastly, we also have the ability to digitize single points. Points can be drawn on the slicer or on an object in the scene. Points can be either with or without normals. There is one special tool available just for points, and that is the ability to create a normal or an oriented polarity disk on a point. These normals can be flipped when selected. Lastly, in addition to all the specialized tools that we've just discussed, we of course also have the Save button, the Close button, the Undo, the Redo, the Delete, and the Help in our Polyline toolbar. Now that we've seen the different icons available in the toolbar, we'll look at drawing lines in Leapfrog. In this example, I'm going to edit an existing geological model surface. The surface was originally built just from the drill holes, but we also have some surface mapping as well as a cross-section to help refine the surface. To create a new polyline, come over to the Polylines folder, right-click, New Polyline. We can give the polyline a name and click OK. You'll notice upon doing that, our new Polyline Editing toolbar has appeared. If you can't remember which each tool in the toolbar does, simply hover your mouse over the tool and it will tell you what that tool does. Before we start drawing, we need to decide whether or not we want to use points or polylines, and if we're going to use polylines, whether or not we would like to draw 2D polylines on the slicer or 3D polylines on objects in the scene. In this example, I'm going to start with points. You will notice that when I click the Draw Points icon in the toolbar, instructions will appear in the upper left-hand corner. To create a point, simply left-click and then left-click again to create another point. You'll notice right now I'm creating points on the object, or in this case, along this outline of the unit on topography. To create a point with a normal, simply click and drag the mouse. The normal assigns the polarity of the point as well as an orientation, the dip and the azimuth, and this will affect the resulting surface accordingly. To exit drawing mode, simply right-click. If you're happy with these points, we can click Save in the toolbar to save them. To move a point, simply hover over the point and you'll see the instructions appear in the upper left-hand corner. If I simply click and drag a point, it will move it relative to the screen, but it will no longer stay on the topography. If I would like to move the point along the surface, click the Control key to move the point, and it will remain on topography. To add a normal to a point, simply select the point you would like the normal, and then come up here and click to add the normal. I can modify the orientation of the normal by simply clicking and dragging these arrows, so I can modify the dip and the azimuth of the point. If I don't wish to have the normal on this point, I can simply click this button again to remove it. For those of you familiar with previous versions of Leapfrog Geo, the ability to draw points with normals can replace some applications previously covered by creating new structural data. Of course, you can still create structural data, but this oriented point functionality in the Polyline tool can now help differentiate between measured structural data, still imported here in the structural modeling folder, and on-the-fly interpretations such as editing points in the Polylines tool, which I just did.
Next, we'll take a look at drawing a 3D polyline along the topography. 3D polylines can be drawn on or between any objects in your scene. Start by clicking the Draw Lines button, and then to draw a 3D polyline, ensure the Draw on Objects button is also selected. The easiest way to draw a curved 3D polyline is to start with straight segments by simply clicking the left mouse button to produce straight segments. And then once the line is drawn, I'll curve them using the Curve Segments button in just a moment. Once I'm done drawing the line, I can right-click once to finish the line and right-click a second time to get out of the line drawing tool. I can then go up to this button here and make the line segment curved. You'll see a few things going on here with this line segment. First, we have the automatic tangent that was oriented based on the direction I was looking when I drew the line. And I also have my normal ribbon. This ribbon can be toggled on and off by selecting this button here. And we can also show the surface ribbon, which is perpendicular to the surface, by selecting this button here. You'll notice in addition to the Make Selected Segments Straight and Make Selected Segments Curved, we also have the ability to add or reorient the tangent of the line, as well as flip the selected tangents or disks. Essentially, this button allows you to flip the polarity of the line. So in this case, if I wished to reorient this line, I could simply select a point and either select this button to add or reorient the tangent line, or I can simply select the A button on the keyboard, and you'll notice I have now added a new tangent at that point, and that has affected the orientation of that ribbon. To flip the polarity of this entire polyline, double-click it so the entire polyline becomes selected. At this point, I can select this Flip to flip the polarity of that polyline. If I would like to remove these tangents altogether, I can simply select the tangent and click Delete. You will know this is a true 3D polyline because if I were to turn off the topography, you'll be able to see that it actually exists in 3D and not along any sort of slicer. You can also tell it's a 3D polyline because of this dashed appearance along the line. You are able to control the shape of this line a little more tightly by moving the nodes and these Bezier line controls. You can show those Bezier control points by selecting the Show Bezier Control Points option in the Properties panel for your polyline. You simply tick the button on and off to show those lines. I can move nodes by simply clicking the Control key on the keyboard and moving the nodes up and down. I could add a new node by selecting a point and clicking this Add Node on the line. I've now simply added a node, and again, holding the Control key can manipulate the position of that node. If I wish to continue drawing the line, I would simply come back up here to the Draw Lines object and continue drawing my line. Again, it's easiest to start with straight segments and then make those straight segments curved, and then manipulate those segments by holding the Control key and moving the nodes around. And if you need to alter the Bezier control lines, you can do that as well by simply selecting them and pulling them out to the desired shape. When you're happy with your polyline, you can simply select the Save button in the top toolbar. Now that we've created our points and our 3D polyline, let's see how it affects the surface. To do so, we can add this polyline to our diorite basement surface in our geological model by simply right-clicking Add Polylines. We can select the correct polyline and click OK. In this case, you can see that some interesting things has happened to our surface, including it inverting on itself up here. But that's just a matter of polarity. So I can simply click on this disk, flip the polarity, save, and you'll notice that the surface now constructs itself in the appropriate fashion. If we come down here, we notice we have the same issue with this polyline here. So again, we can simply double-click the polyline, flip the polarity, and click Save. And now our surface much more closely approximates our drawn polyline. Now that we're familiar with points and straight and curved 3D polylines, we'll take a look at 2D polylines. For this, we'll look at editing the surface based on an imported cross-section. I have my cross-section here in the scene, so I will simply slice along that cross-section by slicing in any orientation and then setting to the cross-section. And you'll see here that this volume should close off on this side, but it doesn't. So we can simply use a polyline edit drawn on a slicer in 2 dimensions to have it honor this appropriately. To do that, we will again select the Draw Lines, but this time we will use the Draw on Slicer icon in the toolbar. Once you've selected that, the drawing process is exactly the same. I can simply draw straight segments. When I'm done drawing the line, right-click once to terminate the line, right-click a second time to get my cursor back. I can then make the segments curved so that they more appropriately follow that contact. And then again, I can simply select Save, and again, the surface will update to follow my polyline. You will notice that in addition to the polyline tools we've already seen, 2D lines have 2 additional tools available. The first one is to make the selected lines 3D so that you can then snap them to other objects in the scene. And the other option is to set the slicer to the selected 2D line. That means if you get out of the slice mode, but would like to come back into the slice mode to edit this particular line, you can simply select this icon to come back to this slice. If we would like to see it unsliced, there we go. At this point, we could continue adding a polyline around the outline of this purple unit for our modeled surface to fully match our mapped contact. Now that we've seen the Polyline tool in action, I'll mention that there are a number of Polyline hotkeys that can be used while drawing polylines. These hotkeys can be seen by hovering over the different Polyline tools, and you'll see in blue it indicates the appropriate hotkey. There's also a list of available Polyline hotkeys here. The Polylines overview presentation seen in this video is available by clicking the Downloads button in the upper right-hand corner of this screen.